Welcome to The Explainer. Today, we're going to tackle one of the biggest and frankly most expensive roadblocks in building really powerful AI agents. And we're going to explore a new architecture that's designed to solve it for good. All right, so here's the plan. First, we'll dive into the problem, something I'm sure a lot of you have run into. Then, we'll pull back the curtain on this really elegant three-layer architecture that fixes it. And finally, we'll walk through how it all clicks together, using a great analogy and some super clever real-world techniques.
So, if you've ever tried to build a serious, enterprise-grade AI agent, you have, almost certainly, slammed right into what we call the context trap.
It's a story you've probably lived through. You're trying to get your agent to do a complex task, so you feed it more data, maybe thousands of rows from a spreadsheet or a bunch of dense PDFs. And bam, all of a sudden performance just grinds to a halt and your costs go through the roof.
And this chart, wow, it just lays out the painful truth perfectly. As you stuff more and more information into that context window, your token costs and the agent's error rate, they don't just go up, they explode. It's a model that just doesn't scale.
So this whole mess boils down to two critical failures. First, token bankruptcy, which is a fancy way of saying your costs are spinning out of control. And second, context pollution, where the agent's working memory gets so jammed with information that it just gets confused and starts making mistakes, or even worse, hallucinate.
Okay, so let's talk about the solution. And this isn't just some quick fix. It's a really fundamental shift in how we design these systems. We're moving way beyond simple chatbots and into a robust, hybrid architecture that's actually built for complex work. The absolute key, the core idea, is to cleanly separate what the agent needs to do, that's the process, from the raw information it uses and the specific tools it has. This separation is the foundation for everything that follows.
So here are the three layers that make it all happen. Up top, you've got CrewAI Flows, acting as the conductor, managing the overall workflow. In the middle, you have deep agents doing the heavy cognitive lifting. And then at the bottom, there's the interface layer, which uses Anthropic skills and its Model Context Protocol, or MCP, to give the agent tools in the smartest way possible.
All right, let's really dig into the core philosophy that powers this whole architecture. It's called the zero-content state.
The central idea is actually a classic concept from computer science called pass by reference. So instead of handing the entire text of a book from one agent to another, you just pass its library card number. The actual book, the data, it stays right where it is.
And the difference this makes in practice is, well, it's dramatic. The old way completely clogs the system by passing around huge chunks of raw data. Our new architecture, it just passes a simple, tiny reference, keeping the whole process incredibly lean and fast.
Now, to really make this whole thing click, let's use an analogy that I think perfectly explains how these layers all work together in harmony, a good old public library.
Okay, so picture this. The CrewAI flow is the librarian at the main desk. They manage the master plan using the card catalog, that's our state, which only holds references to the books, not the actual books. The deep agent is the researcher. They take a reference from the librarian, go into the stacks, which is our file system, read the book right there, and come back with only their notes. And finally, Anthropic skills are like a special equipment room. The researcher doesn't lug every tool around with them. They just see a sign for a tool they might need and only go in to use it if the job calls for it.
All right, let's zoom in on that final piece of the analogy, the tool room, and see how we can make our agents' tools unbelievably efficient.
This technique is called progressive discovery. Basically, the agent gets to know its tools on a strict need-to-know basis. This keeps its working memory, its cognitive load, totally free to focus on the task at hand.
And here's how that's put into practice. It's a simple SKILL.md file. When the process starts, the agent only reads this tiny little metadata summary at the top. We're talking maybe 100 tokens. It completely ignores the full instruction manual below unless it's absolutely necessary, saving literally thousands of tokens.
But we can push this efficiency idea even further. See, instead of having an agent use a complex tool directly, which would clog up its context, we can have it do what it's amazing at, write a little snippet of code to use that tool remotely.
I mean, just look at the power of this. It's incredible. Instead of trying to load 10,000 rows from a spreadsheet into its brain, the agent just writes a few lines of code to filter all that data somewhere else. The only thing that ever comes back to it is the final tiny result. The result is just staggering.
For this kind of data analysis, this single change leads to a 98.7% reduction in token usage. That isn't just an improvement, it's a complete game changer. It makes large-scale data analysis with AI agents actually feasible.
So when you combine these three layers, the structured orchestration, the externalized memory, and these on-demand smart tools, you fundamentally change what is even possible with AI agents. This architecture just delivers wins across the board. You get radically lower costs, much higher reliability because you're avoiding all that confusion, and even better security since the code can be run in a safe, sandboxed environment. And because the agent's memory is now the entire file system, its capacity for context becomes, well, for all practical purposes, it's infinite. This shift takes us so far beyond simple chatbots. It allows us to create truly complex, autonomous systems that can reason over massive, and I mean massive, amounts of information. The context trap is broken. The agent's memory is now unbound. So the real question is, what will you build with it?